Welcome to Proteus Circuit Simulation Part 3. In this video, you're going to learn how to use Ohm meter and also understand how to use a variable resistor. There are two categories. One is the passive and other one is active. You're going to see how to measure the resistance of fixed resistor, resistors in parallel and resistors in series parallel, and also the resistance in a variable resistor. And I'm going to show you how to build a voltage divider using the variable resistor. So I already got this Proteus running with the empty project. So first I'm going to add the Ohm meter. Click on the pick devices and type Ohm meter. So this is the one. Double click. You can see the Ohm meter is added to your project. I'm also going to choose few fixed resistor. So you can type the min RES followed by the resistance value. Say min RES 220. If you type like this, you'll end up getting these two numbers, these two entries. So this is the resistance or resistor with 220 ohms, and this one is the 220k. So I'm going to pick both. I'm also going to choose a resistor in the range of mega ohms. So type min RES, say 1M. So you got 1 megabyte. You can see 1 megabyte. So I'm going to choose that. Let's try 10M. You can see this resistor with 10 megabyte as well. So double click that as well. Now I'm going to drag and drop the Ohm meter. So I'm going to zoom this a little bit. So first thing what you have to do is you have to short these two lines. So there are 4 pins in the Ohm meter. You have to short the pairs. So I'm not sure why this Ohm meter has got 4 wires. I'm going to bring this 220 ohm resistor. Now you can double click and change the value of this resistance. So you can make this as 500 ohm, or looks like these are the standard resistors you can buy. Now in order to measure this, I'm going to connect one end of this Ohm meter to this resistor, the other end as well. So now we have got the connection done. If you hit the simulate button, play button, you can see that the Ohm meter is showing 220 ohms. So that's what you need to know about using the Ohm meter. So let's try with the other resistance as well. So I'm going to stop the simulation, bring the 220k. You can have any number of Ohm meters in your circuit simulation. So as we did before, short these two lines and short these two lines. So this basically what you're trying to do here is converting this 4 pins to 2 pin. So connect one end to here, the other end here, and run. Now the second Ohm meter says max. So the reason why you get max is if you double click and see the properties of this Ohm meter, it is set to the range as ohms. So you have to set that as a kilo ohm or a mega ohm. So I'm going to set this as kilo ohm. Now when you hit the simulation, you can see that it is showing 220 kilo ohms. So stop the simulation, bring one more Ohm meter and the mega ohm resistor. So like we did before, short these two and connect. You can see here this Ohm meter is set to the range to read in ohms. Now if you hit the simulation, so it's very obvious that you're going to see the max in this Ohm meter. So it says max. So you have to change the range to mega ohm. Okay. And you can see here, so it's not precisely 10 mega ohm, it's 9.99 mega ohm, which is more or less near to the 10 mega ohm. Now you can select all and delete. Either you can go to edit and just select all and delete, or you could have used this selection and drag a box to select all the drawings on your screen. So next I'm going to show you how to use the variable resistors. This is just a very brief information about the variable resistors. So as the name says, you can vary the resistance of this device. So there are, if you take this as an example, so there will be 3 terminals in a variable resistor, and you can visualize the 3 terminals like this. Now this is a variable resistors with the capacity of 10K, and there is a center tapping. Now in this scenario, the center tapping is at the center, so you can think of this variable resistors as having 2 independent resistors, one on the top, other at the bottom. Because the tapping is at the center, the top and the bottom resistance are 5K each, because the total resistance of this variable resistor is 10K. So in the second scenario, I have moved the center tapping towards the top, so you got less resistance on the top. Now this is an example where the bottom resistance would be 7.5K and the top resistance will be 2.5K, sorry. And in the third scenario, I have moved the center tapping towards the bottom, so obviously you got less resistance at the bottom. So in this scenario, the top resistance will be 7.5K and the bottom one is 2.5K. You can also use the variable resistors to provide one single resistance. So what I've done here is the center tapping, I've connected that to the top connector. Now this is like this is a short circuit here. So you can think there's a 2 wire this and that, because this is like a short, so this resistance will play no role in your circuit diagram. So by adjusting the center tapping, you will get a different range of resistance at the bottom. So as I mentioned here, in this type of configuration, only the lower half of the resistors. Next I'm going to show you how to use the pod. So from the PIC device type pot, you can see there are 3 entries here. 2 are active, the middle one, this is not active, this could be the passive. I'm going to choose the pod active, double click, and the second one pod. Next I'm going to show you how to use a variable resistor. So from the PIC device type pot. Now from here I'm going to choose the pot HC, double click, and I'm going to choose the second one, pod device. So have an instance of that on your worksheet. Now this is a passive one. I don't find any use of this, or maybe I don't know how to use this. You're going to see that what's the drawback with this passive variable resistor. Draw the HG. Now this is an active one. You can see here the tapping is at the center. It's a 50% from the bottom. You can use this up and down arrow to change the center tapping. Now I'm going to, you can see here the total resistance is 1K and 1K here as well. And I'm going to bring this to the center, 50%. Now zoom a little bit. Now we know that a variable resistors will give you 2 independent resistors, the top and the bottom. In this scenario, the top should be 500 and the bottom should be 500 ohms. Now I'm going to bring an ohm meter. We'll have 2 ohm meters, one for this, the other one for the active one. As we did before, connect these 2 points and change this to, you can have ohms. Okay, connect this here and connect this here. And simulate. You can see now both are showing 1000 ohms. Both are 1000 ohms. Because we have connected to the top and the bottom lead, so we're not connected to the center tapping. So what you see here is the total resistance of this device, which is 1000 ohm. I'm going to stop the simulation. This time I'm going to remove this connection first. Click on the selection arrow and just delete, and I'm going to delete this as well. So what I'm going to do now is just connect the center tappings and the bottom one. So you are measuring the resistance from the center tapping towards the bottom one. I'm going to do the same thing here. So you need to move this one and connect the center tapping. Usually when you build the circuit, you don't keep this lead open, because that's going to generate the noise. So let's try to simulate this and see. So I'm getting the center tapping as the resistance from the center to the bottom is 500 ohms, and here also I'm going to get 500 as well. So there's no way you can change the center tappings in this variable resistor. Whereas here you can use the arrows. Now I'm moving this up arrow, so you're moving the center tapping towards the top, so you get more resistance at the bottom. So we are measuring the resistance from the center to the bottom. So you can see that resistance start increasing. You can also play with the bottom arrow, reduces. Now the good thing about this resistor is, so once you know have got the resistance you want for a circuit design, you just have to make a note of this percentage, and you can have this as a initial value of the resistor. I can stop this thing. So I'm going to remove the passive pod. So first I'm going to select all these components and delete, and I'm going to delete this from the list. So go back to the device pick and choose the pod and bring this pod back to the first one. Now if you drag and drop this, now this is also an active variable resistor, but here you don't see the percentage on the component. If you compare these two, the only difference is here you can see the percentage, how far you are from the bottom of this, whereas here you don't. That's the only difference. Next you're going to learn how to measure the resistance from both the upper and the bottom part. I'm going to select all these components and delete. Now bring a pod, bring the HG one, and I'm going to bring one. You need 2 ohm meter, so one for the top and one for the bottom. So as we did before, connect these 2 lines. Now I'm going to connect this end over here and this one. Now if you noticed here, so this is the auto routing. It has taken a path, what you see here, but you have to keep in mind these wires are not shorted. So only when you see this dot here, like a junction, that's where the connection is made, not here. So you can try to move this further up or down. Oh, this is still worse now. So probably now what you can do is just delete them. Probably do it again. Yeah, so I'm going to have this one connected to one end here and the other end yeah. So this is still a 1K, so we can have this ohms range. Now simulate. You can see because the tapping, the center tapping is at 50%, both ohmmeter showing 500 ohms. Now if you move down, you can see here you're moving the center tapping towards the bottom, so there is less resistance. So you can see it's 450 here, whereas 550 there. So the total resistance, both the top and the bottom part, must be equal to 1K. So this is an example of a series and parallel resistance. As you can see here, I've got three 220 ohm resistors, and you know that these two are parallel, and that's in series with the 220. So you can easily find out, if you've got a calculator, or this can be done mentally. See, how do you find out whether something is in series or parallel? Now assume that there's a current flowing here in this direction. Now this current is going to split into this as well as one in the branch. So now this tells us that these two branches are in parallel. When you start simplifying the circuit, so what you end up doing is you're going to replace this bit, because these two are in parallel, with the resultant resistance. So the resultant of these two, 220 ohm is 110. So this would be equivalent to 220 in series with 110. Total it is 330. Now if you simulate this, you can see that the ohm meter shows is 330. So I added few more resistors in series and parallel, and if I simulate this now, you get the total resistance that you see between these two terminals is at 351.6 ohms. So like that you can find the resistance of any circuit. Say for example, you're working on the Thevenin's or a Norton theorem. So you just bring the ohm meter and connect at two different points where you want to find the resistance. That's just an introduction to how you find the resistance of a parallel resistor. Now I've got three resistors in parallel. If you think the current enters the resistance R1, it splits into R3 and R2. So you know that R3 and R2 are in parallel because there is a split in the current. So this is what you know from your earlier classes. To find the total resistance of a parallel circuit, you use 1 by total resistance is equal to 1 by R2 plus 1 by R3. It's very easy to find the total resistance or the equivalent resistance using a calculator. So you can apply basic mathematics and get, so 1 by RT is equal to, instead of writing 1 by R2, I'm going to write R2 to the power of minus 1. So just taking the numerator denominator, so R3 to the power of minus 1. So after you do this calculation, if you're using calculator, just type say 10 minus 1 plus 15 minus 1, and the answer get again the reciprocal of that, so that will give the total resistance. So next I'm going to show you how to build a simple voltage divider using the variable resistance we have seen before. Now this is the simple circuit, okay, you will come across when you start reading about the voltage divider. So I have got a power source, a battery, that's this is the battery, connected to two resistors R1 and R2, and you have to find out what's the voltage drop across R1 and R2. So you know that the voltage across R1, V1 is equal to the total current times R1, and V2 is equal to I times R2. But the total current in this circuit is the voltage divided by the total resistance, that is V by RT. If you substitute V by RT into this equation here, you get V by RT times R1, V by RT times R2. Just rearrange the equation, you get V times R1 by RT, V is equal to R2 by RT. Now you can see here R1 by RT is nothing but the ratio of the resistance R1 in the total circuit. So you can say that in a voltage divider, the voltage divides in a ratio of the resistance. Now we are going to build this simple circuit. I'm going to use the variable resistor. We're going to connect 2 Ohm meter, and we'll play with changing the resistance, changing the center tapping, so that you get a different voltage drop on the top and the bottom. So I'm going to edit, select all and delete. Now you can't delete because the simulation is still going on. You have to first stop the simulation, then I can go and delete. I'm going to bring a pod and bring a voltage source, so you need a battery. So I'm going to bring type battery, so choose a DC voltage source. I'm going to have one instance of that here. Let it be 12 volts. Now we're going to divide 12 volts between these two resistors. You need 2 voltmeter to measure. So I'm going to connect So if you go to the virtual instrument, you can bring the DC voltmeter. You can also make it a bit fancy by introducing an ammeter. Now the reason why I'm doing this is so that you are comfortable using this variable resistors. So I'm going to connect one end. Now there's something else I found in this software. If you go to the set animation option, you can show the wire voltage by color and the wire current by arrows. So this has got some nice information on the diagram. It shows you the direction of the current. I'm going to connect from here to here and here to here. I'm going to connect this to this end and this to this end. Now if I simulate, so you can see here both the voltmeter is showing 6 volts. So it's very obvious because the center tapping is in the tapping is in the center. So you got equal resistance on the top and the bottom. So it has to be an equal voltage drop. Now if I change, I'm going to make the resistance at the bottom a bit less. You can see that the voltage at the bottom resistor is lesser than the top. If you do the other way around, so I'm going to move this the center tapping upwards so that you get more resistance at the bottom, because we know that in a voltage divider the voltage divides in ratios. So the bottom resistance is more than the top, so you will have a more voltage drop here. And as I mentioned before, you can see this the arrows that shows the direction of the current flow. So that's all I got in this video. Thanks for watching.